Find the instantaneous speed of a rock whose fall is modeled by the function y equals 16t squared, where t is time in seconds and y is feet. And we need to find that at t equals 4 seconds. So this is very similar to the last problem, where we need to find instantaneous velocity is the instantaneous speed, is the slope of the tangent line. And what function are we looking at? So here's y and here's t. Looking at a parabola like this, y equals 16t squared. And we're looking at the point t equals 4. So this is seriously not drawn to scale because at t equals 4, the distance the rock has fallen, its position is 4 squared, right? So that's t is 4. So if t is 4, we put it into here. 4 squared is 16, times 16 is 256. So here's 256. And we want the slope of the tangent line right here. And that will give us the instantaneous speed. So if we do, and I'm going to draw it a little larger here, so let's take the distance h, and that would make this point 4 plus h. Remember, the goal is to find the slope of the tangent line, slope of the secant line from 4 to 4 plus h, and then let h get really small. And here at 4 plus h, what's the height? What's the height of the rock at 4 plus h? Man, I really didn't draw this to scale, so this is supposed to go right up to here. What's the height? Well, it is 16 times 4 plus h squared, right? Because we're just putting 4 plus h into the function for t to come up with the distance. Okay, so now the next step is to find the slope. The slope is the change in y, so that's 16 times 4 plus h squared, right? It changed from that amount to 256. How do you find the change? You subtract, and it changed along here, right? So this point is associated with this x value, and this point is associated with this x value, so we have to make sure we use it in the same order. This is 4 plus h minus 4. That's the change in x. And remember, our intent is to take the limit of this slope as h goes to 0, and that'll give us the tangent, the slope of the tangent. So happily cancel those. And the next step is we're going to FOIL this. So we have the limit as h goes to 0 of 16. Let's FOIL 4 plus h. That's 16 plus 8h plus h squared minus 256. Okay, I just copied that minus 256 down like that after foiling. And this is all over h. And the limit, now is when you start getting excited about canceling stuff. 16 times 16 is 256. 16 times a positive 8h is, well, 16 times 10 is 160 minus 32 is 128. Sounds about right, 128h plus 16 times h squared. All I did was distribute this 16 over each of these 3 terms to get 1, 2, 3 terms. Okay, and then we still have this minus 256 over here, but not for long, because we can nail those 2 guys. And the next step is we have the limit as h goes to 0 of, okay, so we have the 256 is canceled. We have 128h plus 16h squared all over h. The top is just saying please factor out an h.
For the show, everybody.
And so in the top we have h times 128 plus 16h over h. Again, let's cancel some h's this time, and we're left now. We only have this expression left, 128 minus 16h. As h approaches 0, this just approaches 128, and we have to make sure we include units. Feet per second, and that's our answer. And 32 times 4. Okay, that's the answer. So this one I will answer quickly. The be careful is that, remember, the limit as x approaches 0 of sine of x over x, this is not that this is equal to 1. This is completely unhelpful in this case because x is approaching positive infinity. So pretty sneaky, Mr. Lucetta, but we are not going to fall into your trap. Okay, so all I did was say that sine of x minus 6x over x is equal to these two terms separated. And this is equal to the limit as x goes to infinity of sine of x over x minus the limit as x goes to infinity of 6x over x. Well, we can see that these x's are going to cancel. So this part right here is going to be 6. So I'm going to put a minus there. And as x goes to infinity, sine of x just goes back and forth between minus 1 and 1. And x goes to infinity, so this part would be 0. So the answer is minus 6.